Hello friends, welcome to Diwakar Physics. Today we'll discuss more MCQs, multiple choice questions from chapters 1, 2 and 3. Okay, so let us start. So question number 1 is, a physical balance works with the concept of couple. True or false? So it's false. Okay, so in the physical balance, so two forces act in the same direction. So this is not the example of couple. In the couple, two forces acts in the opposite direction, the different lines of action. So here, two forces are acting at different lines of action, but they are in the same direction. So this is not working with the concept of moment of couple. So this is false. So next question is, acceleration of a body in equilibrium is maximum. Okay, so true or false? So in equilibrium, net force is 0. So when there is no force, so then there will be no acceleration. So acceleration is 0 in a body in equilibrium. So it's false. So acceleration is 0, not maximum. So it's false. Next is, Earth moves around the sun with uniform speed. So it's true or false? So answer is true. So Earth moves around with the uniform speed. So remember, it's a speed. So speed is uniform, but if velocity is given uniform, then it will be wrong. So Earth moves around the sun with uniform velocity, then it will be false. But here it is uniform speed. So that's why it is true. So in circular motion, velocity is variable, but speed is uniform. So remember that. Question number 4. The moment of force is a vector quantity. So it is a vector quantity. Torque is a vector quantity. So next question. A uniform half meter scale of weight 20 gram force is pivoted at 50 centimeter mark. The least force which can keep it horizontal is, so what is the least force which we can apply on the scale to keep it horizontal? Okay, so actually when (20 gram) force, so you can solve like this. So this half meter scale, so 0 and 50 centimeter. Okay, it is a half meter scale. So instantly you will take weight acts at 25 centimeter mark. So 20 gram force acts here at the center of gravity, and it is pivoted here. So due to which this force, so it will turn anti-clockwise direction. Now you have to produce clockwise direction to keep it horizontal. Otherwise it will turn like this because of this weight. Now to keep it horizontal, you have to apply force so that clockwise movement is produced. And you see in the question, minimum force, that means maximum distance from the axis of rotation. So from here you have to apply the force, the maximum distance, that means on the other end. So you have to apply force here to keep it horizontal. Now how much force? Then this force will produce clockwise moment. So what is the distance? 50. F into 50, moment produced by this force, F into total distance. Remember, not from here, from axis of rotation, from the pivot point you have to take the distance. Then is there any clockwise movement? Anti-clockwise movement? Yes, there is. So 20 gram force is producing anti-clockwise moment. So what is the moment of 20 gram force? 20 gram force into its distance from the axis of rotation. As this is at 25 centimeter, pivot at 50, so 50 minus 25. Then F into 50 equals to 20 into 25. So F equals to 20 into 25 by 50. So 10 gram force should be applied here to keep it, 10 to keep it horizontal. So that's why let us search 10 gram force option. So this is the answer. So 10 gram force is the option or correct option, you can say. Okay, we'll move to next question. When a hollow cone is filled with ice cream, okay, so ice cream cone is hollow and it is filled with ice cream. The position of its center of gravity remains the same. Now when we fill that hollow cone with ice cream, now it will be a solid cone, complete. Okay, so that means more mass is there added in that hollow space. So that's why the position of the center of gravity will be shifted. As you know, for the solid cone and hollow cone, so here it is h by 4 and here it is h by 3, right? So position of center of gravity for solid cone h by 4 and hollow cone h by 3. So hollow cone to solid cone, we are converting hollow cone to solid cone. So obviously the position of center of gravity will change, so the answer is false. Here it is given remains the same, so the answer is false. Okay, next question is net moment of force on a scale of negligible weight of 6 cm pivoted at 2 cm mark with weights 5 Newton and 3 Newton, forces suspended at 0 cm and 6 cm mark is, so this various options are given. So this is a numerical, so let us solve the numerical. So the question is about scale, similar one as we have done here. So 6 centimeters, so this is 6 centimeter long and it is pivoted at 2 centimeter mark. And weights are suspended 5 Newton from 0 centimeter and 3 Newton at 6 centimeter. 3 Newton. So this is the diagram. So and here weight of the scale is negligible, so we will not take any weight at the center of gravity. Okay, so that's why negligible weight is given there. Now we have two forces producing moments, so then we have to calculate the net moment produced by these forces. So what is the moment produced by this force? 3 Newton. So 3 into its distance from here to the pivot point. So what is the distance between 2 centimeter mark and 6 centimeter mark? So 6 minus 2. So this is the moment produced by this force. What is the moment? Clockwise, and clockwise is taken negative. Okay, now this force is also producing the moment 5 Newton force, and you see what is the moment of force produced by this? 5 into its distance, force into distance. So 5 into, it is suspended at 0 and pivoted at 2, that means 0 to 2, so obviously 2, or 2 minus 0 also you can write. Now this produces anti-clockwise, so write plus. Now this is the net moment. So calculate minus 3 into 4 plus 5 into 2. So minus 12 plus 10. So minus 2 Newton centimeter. Forces are given in Newton, distance is given in centimeter. So 2 Newton centimeter. Minus 2, in fact. Minus 2 Newton centimeter. Now let us see the options. 22 Newton meter minus 22 Newton centimeter minus 22 Newton centimeter minus 2 Newton centimeter plus 2 Newton centimeter. So we have got, this is the correct. So C option is correct. So clockwise moment negative, anti-clockwise moment positive. Remember this. Next is the work done by a force on a car of weight 100 kgf. Okay, 100 kgf moving with 50 km per hour on a horizontal road is calculated by formula half mv square, calculated by formula mgh, 0 joule and maximum positive work. So how to find the work done by force of gravity? Okay, so here you see the car is moving on a horizontal road. Yes. So this is the displacement, and this is the work done by a force of gravity. So force of gravity. So gravity weight acts downwards. So work done by a force of gravity will be 0 in this case, because force of gravity is downwards and displacement is horizontal, forward. So vertical and horizontal, they are 90 degree. So work done is 0. So no need to use any formula. So work done is 0 joule. So remember, that's why force of gravity. Okay, force of gravity downwards, motion, displacement horizontal. So theta is 90. So work done is 0. Next question is, a body of mass 40 kg falls from a height of 5 meter, and after striking the ground it rebounds to some height. On striking the ground it loses 800 joule. The height to which it raises is 8 meter, 3 meter, 4 meter, 2 meter. So it is bouncing back, then how high it will rise? So that is the question. So when it is at the height of 5 meter initially, then what is the energy? So which energy is there? mgh. Okay, mgh. Suppose it is dropped from here, then here mgh, and it will go up to this, suppose here up to this height, then here also mgh, but there is a loss of height. Why? Because there is 800 joule of energy is lost in the form of sound, heat, like that. So we can write mgh equals to 800 plus mgh dash. Suppose this is h dash, it is raised to h dash. So this concept you can use. Total energy mgh here, when it strikes the ground it loses 800 joule, then again some remaining energy is there, due to which it gains some height. and when it gains some height, supposed to height h dash, then it gains mgh. That means this much energy is there with the mass. So mgh, total energy, initial energy, is equal to 800 plus the energy gained by bouncing back. Okay, then you can put the values and calculate. Now see, this is the situation. 40 mass, 10 is the value of g, height initially height is 5, then mass 40, g10, h dash. So now you can solve it. So I think you can cancel these zeros, 2 zeros in all the terms, and then here you can write 2, then 5 is equal to 2 plus h dash. So h dash is equal to 5 minus 2, that is 3 meter. So that's why 3 meter is the option. So this is the answer. Next question is the work done by frictional force is negative. Okay, so this is factual question. Friction. So just the reason is when the body moves this side, frictional force acts in the opposite direction. So that's why negative work. Theta is 180. Next is 1 horsepower equals to 746 watt. So this is also factual question. Chemical energy changes to electrical energy in biogas burner, LPG burner, solar cell, electrical cell. So it's electrical cell. Energy stored in the compressed spring makes the body of mass 5 kg move with the speed of 12 meter per second. The potential energy stored in the spring is, so here you can calculate. So compressed spring has potential energy, elastic potential energy. Okay, now it is making the body move. That means the body which is moving is getting kinetic energy out of that potential energy stored. Okay, so that's why whatever kinetic energy is gained by the moving body is equal to the potential energy stored in the spring. So mass is 5 and velocity is 12 meter per second. So what is the formula of kinetic energy? Half mv square. So potential energy is equal to kinetic energy gained by the body. So half mass is 5 kg, speed is 12 meter per second. So 5 into 12 into 12. 30 into 12. So 360 joule. So 360 joule is the correct option. This is the answer. Okay, next question is also based on conservation of energy. A ball of mass 200 gram is thrown vertically upwards with an initial velocity of 20 meter per second. The energy at the maximum height is, so here also we give energy, initial energy as kinetic energy, because you are throwing a body in upward direction. So initially we are providing kinetic energy. As it goes up, velocity decreases due to acceleration due to gravity. Then at the maximum height, kinetic energy is 0, but at the same time the body gains height, so it gains potential energy. So initially whatever energy we give, so we can say that is converted into kinetic energy. So potential energy at the height is equal to kinetic energy at the bottom. So again same formula. So what is the initial velocity? Okay, mass is 200 gram and velocity is 20 meter per second. 200 gram and 20 meter per second. So 200 gram, 20 meter per second square. So here you see units are different. So that's why you need to change this into kg. Let it be in meter per second. SI unit. So 400. Then you can cancel these zeros. Then 40 joule. So 40 joule is the answer. And if you don't convert this 200 gram, then you will get 40,000. So that's why the options are given 40,000 also, 40 joule also. So this is the right answer. Here 40 Newton is also given, 40 erg is also given, but as we have converted it all in SI unit, so your answer will be in SI unit. So 40 joule is the correct answer. Next, a simple machine can act as force multiplier and speed multiplier at the same time. So this is false. So either it will act as force multiplier or as speed multiplier, not together at the same time, because velocity ratio is fixed. For a practical, next question, for a practical single movable pulley, MA is greater than VR, MA is equal to VR, MA is less than VR. Okay, so here so this answer will be correct. So MA is less than VR. This is a practical machine. So practical machine means efficiency will be less, and efficiency is equal to MA by VR for any machine. So efficiency is less, that means MA by VR is less than 1. So MA is less than VR. So this is the option. Okay, for practical machines, MA is less than VR. For ideal machine, MA is equal to VR. So this way you can learn. Next, a simple machine, 17. A simple machine can multiply energy for doing work easily. So this is false, because energy cannot be multiplied. The energy is increased, energy is created by the machine, then which will violate the law of law of conservation of energy, or principle of conservation of energy. So that will be wrong. So machines cannot multiply energy. Frictional force in the axle of a pulley reduces its velocity ratio. So this is also false, because frictional force will reduce mechanical advantage, efficiency, but velocity ratio will remain the same. Next is, a material of a string A is more elastic than the material of string B. The preferred string for the use in block and tackle system is A, B, both, none of the above. So which is more elastic? A is more elastic. So elastic, the string should be perfectly elastic. So as A is more elastic, so this should be preferred to reduce the energy loss or to increase the efficiency. So this is where we can solve. Thank you for watching my video. Keep watching Diwakar Physics.